So now we are discussing chapter number 8. And first is conservation of laws. So here what is the continuity equation? You know that the charges must be conserved. It means the charges can flow in or out must be the same. In any medium, if for the steady state, the charge is flowing into the surface will be the same as taken out from the surface from the other side. So we call it as a conservation of the charges. Simply, we say that the total charge must be conserved. The total charges must be conserved if the total charge in the some volume if the total charges in some volume changes, then exactly the amount of charges the amount of charges must be passed in or out through the surface in or out through the surface q, which is the function of time, number of charges which is a function of time, is equal to rho, which is the function of velocity in time or position in time, into deta. It means the total charge must be conserved. For example, if we have a surface like that, is any surface here, the total charge within this surface must be conserved. Second thing, if the total charge in some volume changes, it means if some of the charges is changes in this, then the number of charges, which is a function of time, in or out must be the same. So this is known as the conservation of the charges. Then Q of t is equal to rho into deta, because this dq over d rho is the deta is equal to density. So this can be written as density, which is the function of position and time, is equal to dq over deta. So this is known as a conservation of charges. So here dq over deta is equal to rho of t. So we can rewrite it as dq over deta. If we multiply it with the area dA, then this equation can be written as r into t into dA perpendicular. So here, if we integrate on both sides, we will get, this is the integral, this is the integral. So here, this can be rewrite as j, or rho of t can be rewrite as d rho over dt is equal to, or dq over dt is equal to the j of dA perpendicular or beta. So d rho over dt into deta is equal to minus divergence of j into deta. So here this can be rewrite as d rho over dt is equal to minus divergence of j, and this is known as a continuity equation. So now here dq over deta, this can be written like that: dq is equal to rho deta over dt, and this is equal to j dot dl. Okay, this is the surface integral. This can be converted into the volume integral by taking the divergence of it here, using divergence theorem here. So in this divergence theorem, the surface integral is converted volume integral by taking the divergence of the current density. So this is equation same. Q is equal to d rho over dt here. This is equal to Q. Okay. So here d rho over dt volume on both sides cancel out. So this is known as a continuity equation. So now in this continuity equation, this proves the law of conservation of the charges. So now what is the pointing theorem now? So now here